Well, good afternoon. It is 3-5 solving two-step equations. So two-step equations have two different operations. And before we get started, I'm going to let you go ahead and write these notes down. So go ahead and hit pause and do that. So now that you have written all of this down, again, two-step equations have two different operations in them. And it's basically taking what we've learned in the last two sections, on section 2 and section 3, and combining those two together, addition or subtraction, and now with multiplication and using division to solve it. So let's take a look at this, and it says first of all you always start on the side with the variable. Same concept that we've been talking about. It's always on that side with the variable. That's what we're trying to get rid of, are the numbers attached with that variable, so that we can have the variable by itself, which would then equal the solution. Step 2 is then undo the addition or subtraction number. So you're going to do addition or subtraction first, which is the number by itself. Okay, that's always the number that's going to be by itself. The one that's with the variable is step 3. That's because it's with a multiplication, like 3n. That's the number with the variable, and that always means multiply. So to undo the multiplication, we're going to divide by itself to each side. So we divide it by 3, and that is what gives us 3 divided by 3 is 1, and 1 times n equals n. That is why we are dividing by itself. Okay? Then you can check your solution. So let's try a problem. I'm going to actually, if you want, you can write this down now, and then we are going to, myself, walk you through this one step at a time. So step 1 again says start on the side with the variable, which is going to be on this left side in this case. Sometimes it will be on the right. Same thing you do if it's on the right, you do the same process. So we're going to start with step 2, or continue with step 2, which is the inverse operation of adding 3. So we're going to subtract 3, or add a negative 3 to both sides. That's the same concept. And so then we end up getting 2x by itself plus 3 and a negative 3 is 0, so we're not going to write that down. And then 9 plus a negative 3, or 9 minus 3, however you want to look at that, gives me 6. So now you have a whole new equation. So now it is simply 2x equals 6, which is what you did on Friday. So now we're going to divide by the number with the variable. Okay, and remember, it's not the opposite of that number, it's that number itself, because like signs will give me a positive number when I divide. So then we end up getting x by itself, because 1, which is 2 divided by 2, which equals 1, is going to multiply with x to give me just x by itself. Then it is 6 divided by 2, which is 3. Now, my suggestion, again, is to go back up here and plug this number in, and 2 times 3 plus 3 more should equal 9, and 2 times 3 is 6, and 6 plus 3 more does indeed equal 9. Okay, so our solution is correct. And again, the solution to that is x equals 3. So let's try some more. So I'm going to let you go ahead and do letter A. So hit pause and solve. So again, we're going to start on the side with the variable, which is over here. Then we're going to start with the number that is by itself, which is the 4. And what we're looking at is this number right here. It is a positive 4, so we'll do a negative 4 to both sides. Adding a negative 4 to both sides is the best way to look at that. So then we end up with adding 5, which is the same thing as positive 5 times r, equals, and a negative 11 plus a negative 4, which would be like signs. Okay, so we would add, and the sign would stay the same. So negative 15. Okay, the reason we don't like to look at this as subtraction, because then we're saying negative 11 minus 4, okay, which we would then have to change it to addition opposite of the second, which gives me the same thing as a negative 4 plus a negative 11. Okay, make sure you understand that we're using those same integer rules. So inverse operation isn't always the best way to describe this. So we're going to then have this new equation, which is a multiplication. So we're going to do the inverse of that, which is divide by the same number, 5, to both sides. And then we get r equals a negative 15 divided by 5, which is 3. Unlike signs, therefore it is negative. And if we plug this in, negative 3 in here, that would give me a negative 15 plus 4. So unlike signs, you would then subtract, and we do get negative 11. Okay? Let's look at our next problem. Go ahead and hit pause and solve this. Again, starting on the side with a variable, number by itself. Okay? This is, and a lot of students struggle with this because they say, well, that's a positive 7. Well, that is true, okay? But if we change this to an addition, an opposite of the second, it is a negative 7. So subtracting 7 or adding a negative 7 is the same thing, okay? It's a negative, okay? So we can change that right away, or we can leave it however you want to look at that. You know, the other way of seeing this is also we've got to get rid of the subtraction sign and the 7. So subtracting 7 would be adding 7, which again, if we change this to addition opposite of the second number, we end up with the same concept. We're adding a negative, or excuse me, adding a positive 7 to both sides. So then we end up with negative 2y equals 7 plus 3, or 3 plus 7, which is 10. Now we have our new equation. We are going to divide by the same number to both sides. And I say same number, it's got to be a negative 2 because like signs are positive. We've got to make this y a positive number or letter, variable. So now we can divide, and 10 divided by 2 is 5. And unlike signs, makes it negative. So if we plug this into this, negative 5, a negative times a negative is a positive, so we get positive 10 plus a negative 7, and we do get 3. Okay, and if we were to eliminate this, or go back to our original problem that said that this was subtracting 7, then it would simply be 10 minus 7. This would be a positive in this case. 10 minus 7, which equals 3. Okay? Both of them work. It's just a matter of how you want to look at it. And some students look at it differently than others. It's just as long as we come to the same understanding. Go ahead and solve this problem. So hit pause and solve. So again, we're starting with the number with the variable, or side with the variable. Number by itself is where we got to get rid of first. So we're going to, since it's adding 8, we're going to subtract 8, or add a negative 8 to both sides. And we get negative 5s equals, and then a negative 2 plus a negative 8 is going to give me a negative 10. Now we're going to divide both sides by negative 5, because a negative times a negative, or excuse me, negative divided by a negative is a positive, and that gives me positive 1, and 1 times s is s. Now we have a negative 10 divided by negative 5, which is 2, and same signs are positive. So my answer is 2. So we can plug it in. Times 2, and a negative 5 times 2 is a negative 10 plus a positive 8, which does indeed equal, since they're unlike signs we subtract, larger number is the sign, or absolute value of the larger number. That's the sign, so therefore it is negative 2. Okay, and that does check out to be correct. Okay, so the answer again to my variable s equals 2. And when we plug it in, it does equal what's on the other side. If you have any questions, again, please make note of that so that we can discuss it further tomorrow. This isn't always the easiest concept. We do realize that. We're going to have to spend some extra time practicing and understanding it in class tomorrow possibly. But do please come with any questions or misunderstandings of it so that we can clarify those before you begin the lesson tomorrow. Have a great evening, and we will see you tomorrow.